Okay, so we're going to talk today about combining algebraic fractions. Now, I'm going to warn you, the algebraic fractions that they give you are very basic because they want you simply to focus on the process. And then we've got some more things that we have to do in order to be able to really do these right. In other words, algebraic fractions have some other pieces that we haven't talked about. We're going to talk about that later, but we have to build some more information, build some more knowledge base before we can work with them. So when you look at these and you think, that's easy, there's nothing to it. Good. That's what we want. Because what we're doing, again, is focusing on just the process of reminding you about how to do fractions, right? It's really not about the algebraic fractions right now. Yesterday, remember, I didn't even write algebraic fractions. I just said multiply or divide fractions. So it's you will have some algebra in here, but that doesn't change things considerably. Okay? All right, so combining algebraic fractions. First is something we talked about yesterday. You must have a common, what? Denominator. Excellent. Those denominators have to be identical. If they're not, you first have to find the, what's it called? Lowest common denominator, or you'll hear me say least common denominator, but they mean the same thing. I'll try to change. Okay? All right, so, right? Step 2. And here's what we did not do yesterday. We just focused on the least common denominator. If you change the denominator, you must also change the numerator. Think about it. You got a piece of pie. It's cut into 6 pieces, right? Then you take another piece of pie, and you only cut it into 4 pieces. Is one piece of the 6th cut pie the same as one piece of the 4th cut pie? No. So if you change the denominator, the number of pieces you've cut something into, it's going to change the number of pieces you have available, right? The size of the pieces. And remember that the numerator tells you how much of something you have. The denominator tells you what kind of things or what kind of pieces you have. Okay? How many of those. So the denominator tells you what the size of the pieces are. The numerator tells you how many of those pieces you have. So like 1/3 tells you have 1 out of the 3 pieces. Right? Remember what fractions mean. And even when they're algebraic, that's still what they mean. So if you change how big they are, it also changes how many of them you can have. Now, we also looked at a process for doing this that you didn't like very much when we did the number section. But again, you're really going to see why, when we start working with these equations, why I really stress this process. Okay? Now, and strangely enough, they do it in the primary level here. I mean, the early years, which I'm really liking. Somebody saw that. So, what you're going to do is, okay, your steps for that. Write the fraction with the new denominator, your LCD, right? Okay. Now, this is only if you have to change the denominator. If the denominators are already the same, who cares? You just go on, do your work. Okay? But if you do change it. Next. Divide the LCD by the old denominator. Okay? Because what we're doing is we're trying to find the missing factor. And to find factors, you use division, right? So we're dividing by the old denominator, the LCD by the old denominator. Because the LCD, if you get the LCD, even though it says least, it's going to be bigger than what you originally started with, right? Because it has to include or encompass more things. Multiply that result. Don't say result. I want you to use the right word. That quotient. Why do I say quotient? Because quotient is the answer you get when you divide. Yeah, divide, guys. Yeah. Okay? Quotient. So multiply that quotient times the numerator to get the new numerator. Now again, remember, it's a lot more difficult to write these things down than it is to actually do them. When you start doing the process, it's just like a machine, okay? So don't think just because there's so much there, right? I'm just trying to think of everything that could possibly happen that would make you go, wait a minute, where'd you get that 7? Okay? Okay? Multiply that quotient. Quotient is the answer you get when you divide, right? In step B, we divided. So whatever you get when you do that division, you're going to take that quotient and multiply it times the numerator of your fraction. Okay? And again, we'll do tons of examples. I'm going to do every even numbered example that they give you for these, which is not a huge amount, but it's some. Okay? Now, this is called the divide, then multiply method by the genius who just wrote that. Because I don't know who started it. I did not invent it, but it needs a name. And remember, in mathematics, we name everything by what we do, right? First, you're going to divide, then you're going to what? Multiply. Okay? All right. So we're going to look at several things. Now, we're not quite finished with the notes yet, so let's continue on with our notes. That's just if you have to change the denominator, which is 98% of the time. But you can also use this for solving equations, which will make your life. You'll be so happy if you learn this process. Okay. Step 3. Okay. Combine the numerators. Okay. And remember, we say combine instead of add or subtract, because now we use signs instead of. Sometimes it looks like a plus, but you actually subtract, right? So combine. Here's a note that I need you to pay attention to. If you have a negative, I don't want to even call it a minus, think of it as negative, in front of a fraction, so, for example, I have negative 3/5, right? So that's what I mean. So there's a negative in front of that fraction, right? Put it in the numerator when combining. The most common mistake that students make with these is they drop the signs. And if you'll put the sign in the numerator, because you're going to be combining the numerators, then you're less likely to drop the sign. So negative 3/5 becomes, that negative is going to move up into the top with the 3. It's going to become negative 3/5. Does that seem okay? There's really no math. Now, you've got to be careful, though, because look at this case. How many terms are there in the numerator? In the numerator, there are two terms up there, right? We have an x term and then the number term, right? So when I move that negative to the numerator, it's going to affect both of those terms. You have to distribute it through the numerator if there's more than one piece. Okay? So this one is going to be, it's going to change my positive x into a what? But it's going to change my negative 1 into a, and there's still all over 3.
So it is 2, you have to distribute the sign to
You distribute it, right. If you put it up into the numerator, it will affect the entire numerator, not just the first term, right? Okay? So you'll have to be careful about that. Now that, they are pretty good. They give you some examples there where that's going to happen, I think. Yeah, oh, well, I lied. But anyway, you'll see it a lot. Okay? Not in this exercise, but later. So, right. You also can't combine numerators if they have brackets. Now, the book just assumes that everybody knows that, right? But I'm wanting to make sure that you really remember that, right? You can't combine, you can't add a bracket to another bracket. You have to eliminate the brackets before you can combine with them, right? And remember that to eliminate the brackets, you simply look inside, then look for an exponent, then look for a coefficient, and then once you've done that, then the bracket's gone. Okay? Now, the book won't mention that, but I think it's worth saying. Yes?
When you're simplifying fractions, do you do what's inside the brackets first before you simplify?
You can't simplify with the bracket either. You have to get rid of the bracket.
Yeah, so you do what's in the bracket.
So you get rid of the brackets, then you can do something. Because remember, a bracket is like having stuff in a box. You really can't see what's inside a box until you open it, right? And that's the same kind of thing. So we're not supposed to know what's inside the bracket. It's a bracket until we open it up and do the math. Okay? Right? Now, having said that, if I see that a bracket later, we're going to see that if we have exactly the same bracket, then I don't have to worry about expanding it. Because anything that's exactly the same divided by itself becomes a what?
1.
No matter how big or how small. Okay? So we'll look at those later. That won't happen to you yet. But it'll happen to you a lot later. Okay? All right. For now, though, multiply out those brackets. And when you're combining, you will later too. Okay? Then, so combine the numerators. And here's another part where people go wrong. Only the numerator changes. The denominator doesn't change. If you've gone through all the trouble of getting a new denominator, don't mess with it anymore. So if it's over 7, it stays over 7, right? Because you didn't recut that piece of pie, you just have more or less pieces of it, right? So it's only the numerator that changes. So you're going to keep the denominator. So be careful. Some of you are going to have a 7 and a 7 and then turn it into a 14. It's not the way it works, right? If it's out of 7 and out of 7, then it stays out of 7. Think pie. I guess I should say cake. New Zealanders don't eat pie unless it's meat, which is so weird. Sweet pies. So let's look at some examples, guys. So I'm on page 24. We're not going to do any where the denominators are the same because that's just beyond that just doesn't make any sense. So, but on page 24, we're going to look at all of them. Now, if you look in the blue in their description, what they describe is perfectly acceptable and perfectly right, but perfectly confusing.
Yes.
Okay? So, if it makes sense to you, though, because that's the way you learned it, that's fine. But I really want you to give that divide then multiply thing a try. Okay? Not just because it's my way and I think it's better. I never do that. I don't care about that. But I know that you can use it for more things later, right? If you have one tool that you can use for lots of things, that's better than having 25 different tools, right? Okay? All right, here we go. So let's look at the first one, number 2. We have 3x over 7 plus x over 2. So, first of all, the most important thing, though, is to identify the operation. What operation do I have here? Addition. So I'm combining. And I'm combining what kind of numbers? Fractions. Walk yourself through that little process. You're going to hear my voice saying it in your head, which is a good thing because one of the problems is that we don't differentiate when we need to use a different rule, right? So we're combining fractions. In order to combine fractions, what do I know about the denominators? They must be the same. My denominators now are 7 and 2. Are 7 and 2 the same? No. Nope. So I'm going to go off to the side, and I'm going to build my LCD, and I'm going to use that upside down division method. You don't like it? Use some other method? I don't care, right? It's not going to hurt my feelings. I just need you to have a method. Is there anything common to 7 and 2? No. No. So all I'm going to do to get my LCD is simply multiply them together. Right? Now, so my LCD then is 14. But if I change my denominator, what else must I change? The numerator. So look at what I'm going to do. And you've seen this before. I'm just going to write one big fraction with my new numerator. A denominator, I'm sorry. Because my whole point is I need to put them all together anyway, isn't it? So why write it as more than 1 if you're going to turn it into 1? Yeah? Okay. This also keeps you from adding the denominators together, which is a really common mistake. If I change the denominator, I must also change the numerator. And the pattern I'm going to use is called divide, then multiply. Okay? I'm going to take my LCD. I'm just going to write it out for you so you can remember. LCD divided by my original denominator. And I'm going to put that in brackets because that means I need to do it when? First. Excellent. Then I'm going to times or multiply that result times my what? Numerator. Okay. So what is my LCD in this case? 14. What is my first denominator here? 7. What is 14 divided by 7 going to make? 2. And what do I do with that 2? Multiply it times my numerator. Okay. Now, I like to write it down. You don't have to. You can do it in your head. But I like to write it down, especially in the notes. So then it's just 2 times 3x, which is what, guys? 6x, right? Just plain old 6x. 2 times 3 is 6. Nothing times x just stays x, right? Okay? Whatever sign you have, even if it's a positive, let's just start putting all the signs in the numerators. It'll just make your life easier when you're doing these. Okay. Now let's do the next one. 14 divided by what's my denominator there? 2. 14 divided by 2 makes what? 7. And 7 times positive x. And again, that's the reason I put the sign up there because it's not just x, it's what? Positive. And so when you write it down, you're going to need to write that positive. You don't need a positive if it's the first term, but if it's after that, you do, right? So what is 7 times positive x going to make? Positive 7x. Thank you. That's all right. That's okay. Right? Right? It really accentuates the fact that you need to do it. If you always said it, if everybody always said it right, then I wouldn't get a chance to educate you. It's perfect. Yeah. So occasionally y'all can say something wrong just to make it. Right? Now, if you do it this way, it is painfully obvious what to do next. Why? Because, you've like terms to combine in your numerator, right? So what is 6x's plus 7x's going to make? 13. And it's still over what? 14. And there's your answer. Now, sometimes after you combine, they will simplify. But in this case, is there anything common to 13 and 14? No. Is there an x in the top and bottom? No. Nope. So that's your answer. Do you have a question? Yes.
Yes, I do. For the examples we have, I don't know that there's like one where you need to do like more of the...
Yeah, these are really simple examples. Yeah, so it doesn't. So yesterday I made up some that had more, but they will have much more later.
Could we do anything?
I'm not really keen on doing that yet until we've had some more, because there's another piece before. Yeah, there's a little bit more background before.
Okay.
So right now, let's just concentrate on getting the divide, the change the denominator, change the numerator business. Okay, that's where we are now. All right, let's look at another one. So we have, but I'm very happy to know that you're excited to do that. Okay? Now, what I always do is identify the operation first. What operation is indicated here? Subtraction. So we're combining, right? With what kind of numbers? Fractions. When you're combining fractions, we have to have a what? Common denominator. Are 2 and 7 the same now? No, I don't see any reason to go off to the side and do this because we just did 2 and 7. We know the common denominator is what? 14. But what I do want you always to do, and you could do this first if you wanted to, whatever sign you have between the two fractions needs to move where? Up into the numerator. If it's a plus or a minus, just get in the habit of moving it up to the numerator. Okay? And I always draw that little diagram there, circle it and put an arrow, because my brain works that way, right? If I always do something the same exact way, then I remember to do it. If I don't, then I don't remember to do it. So you'll see me draw that every single time. That doesn't mean you have to, though, right? But if you find yourself forgetting things, if you can do little things to remind yourself, then, right, that's the way to get over those problems. If you change the denominator, what else must you change?
Numerator.
And we're going to use that divide, then multiply pattern. So what's my LCD? 14 divided by my first denominator, which is 2. 14 divided by 2 gives me a what?
7.
And I'm going to multiply that 7 times my numerator. So what is 7 times x going to give me? 7x. There you go. And we don't really need to worry about too much about the positive there because it's the first one. Now, if you want to, you could always put a plus, right? Never going to hurt you. Go to the next one. 14 divided by what's the denominator?
7.
Is what? 2. So I'll take 2 times my numerator. So it's 2 times negative 3x, which is what? Negative 6 what? X. Right. Positive times a negative is negative. 2 times 3 is 6. And nothing times x just stays x. Painfully obvious what to do next. What do you think? 7x minus 6x leaves you what? Yes, x over what? 14. Now, that is a perfectly acceptable answer, but what did I tell you we talked about yesterday? Do we like it when there's just an x or just one variable in the numerator? No. The alternate answer to that is to remember the 1 is there, right? Is to put it as 1 over 14 and drop the x where? Off to the side. Those two things are identical. I am not going to count it off right now if you just put x over 14. But you're going to see that they're going to start using that format later, and you will too. And as you move forward in mathematics, you'll have to change it to that in order to make things work. Right? So it just makes sense for you to get used to writing the answer in the right format in the beginning. Okay? How's it look? I hate it that they're using the same numbers, the 14 and 14 business. All right, let's look at the next one because many of you forget. Okay? So what operation do I have indicated?
Subtraction.
Subtraction with what kind of numbers? Fractions. Now, one of the fractions is not a fraction, which means... Yeah, and it needs to be, right? Because if you have fractions take over everything. So what if one of them is not a fraction, we need to make it look like a fraction by putting it over what? 1. Okay? Because remember that if you have fractions, the fractions just take over. You have to use the fraction rules for everything. So, do we have a common denominator? No. Our denominators are 1 and 6, but is there anything that'll divide into 1 and 6 at the same time other than 1? And we don't care about what we're dividing by 1 because it doesn't do you any good. So we're just going to multiply them together, get an LCD of what? 6. If you change the denominator, you must also change the numerator. So we'll write it as one big fraction. And we're going to use that divide then multiply pattern. But before I do that, what am I going to do with this minus that's between them?
Arrow.
Yeah, move it up to the top. Okay? And it doesn't matter if it's a minus or a plus. Just get in the habit of doing it. Now, 6 divided by, what is the first denominator? 1. 6 divided by 1 is 6 times 4 is 24. Right? Dividing by the denominator, multiplied by the numerator. So it's 6 divided by 1. Blah, 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 blah. 6 divided by 1 times 4 is what I did. Some days my mouth just doesn't work.
Wait, do you still need to put the bracket?
I put the bracket just to indicate multiplication. Right? I always use a bracket to indicate multiplication when I'm doing it because then.
Oh, wait, we don't.
All right, now let's do the second one. 6 divided by 6 is 1. And 1 times negative x is negative x or negative 1x. You can put the 1 there right now if you want to, right? It's not wrong. But do I want to leave it in my final answer? No. And then I need to see if I can combine those, but can you take 24 minus x?
No.
Nope. So there's your answer. Can I simplify that 24 and that x? No, because my numerator is not a 24 and an x. It's 24 minus x. This is one thing. Right? Do not simplify it. Now, you're going to learn later that sometimes it can simplify, right? But if you have more than one term in the numerator, you cannot divide something out of one term without dividing it out of the other term. You have to do it, work them equally. So this is a huge problem. Do not do that, right? It's 2 terms. Now, I could create 2 different fractions out of it and then simplify it, but if I did, guess what I'd get right back to? Which is not what I wanted. Right? I want them combined. So leave it as one fake fraction. Do not simplify that 24. Now, what if there was a 24 minus 4x all over 6? Would they all 3 divide by something? Then you can simplify to your heart's content. Right? But you cannot simplify. Okay? You cannot simplify unless something divides into every term. Not just some of them, right? Think of it like this. I'm going to bring candy, but I'm only going to give it to this table. How happy would you all be?
Really happy.
How dead would I be by the time we got out of here, right? Okay? You've got to bring it to everybody. So it's the same thing. If you can't divide away any numbers unless that number appears in how many of them? All of them. Okay? Right? Now, let's look at some more. 3 plus x minus 2 over 5. What operation is indicated? Addition. So combining, right? With what kind of numbers? Fractions. So one of the fractions, that means I need to make the other a fraction by putting it over a 1. In order to combine fractions, I need to have a common denominator. Are they the same right now? No. But if I take them over to look for common factors, there's nothing common, so I'm just going to multiply them together, which means my common denominator is 5. Write one big fraction with 5 on it, because my whole goal is to put them together. Now, but if I change the denominator, I must also change the numerator. And what's the pattern? Divide, then multiply. Okay, everybody? All together, because we're all going to say it together. Ready? Everybody, pay attention. Ready? What is it? Divide, then multiply. Okay? Trust me, participating, saying it along with us will help you remember it. So first of all, I'm going to take 5 divided by what?
1.
Which is?
5.
And I'm going to multiply that 5 times the 3, which gives me 15. This plus needs to go where? In the numerator. Now, it goes to both of them, but is a plus going to change a minus? No. So I don't need to put it in front of the minus because putting plus minus doesn't make any sense. So, but do have it in front of the x. Now, go to the next one. 5 divided by what? 5 is 1. And I'm going to take that 1 times what in the numerator? The entire numerator, right? Okay. So what's 1 times positive x? Okay, the thing that's missing is the sign. I need a positive, right? Plus x. What's 1 times negative 2? There you go. Now I'm done? Why not?
I think
Those are like terms, aren't they? Yeah, there you go. So we can still combine those. So what's 15 minus... So is the x going to change? No. And the only reason I put that first is because we typically like the x terms first, right? But you could have put the number first. It doesn't matter right now. And what's 15 minus 2 going to give me? Make me proud. Positive 13. Excellent. Thank you so much.
Why can't you just do 1 times like the cross multiply?
You can here because there's not a common factor, but don't. It's one of those tricks that works. Sometimes it doesn't work all the time.
When doesn't it work?
It doesn't work if you have more than 2 fractions.
Oh.
And you will. Right? It works on smaller ones, but it doesn't work later. Okay? And sometimes it also gives you bigger numbers that then you have to simplify out later.
That's fine.
All right. No. All right. Ready? One more. 2x minus 1 all over 3 minus 1 over 2. Okay?
Yep.
What operation? Subtraction. With what kind of numbers? Fractions. In order to add or subtract fractions or combine fractions, I have to have a common denominator. My denominators are 3 and 2. Do they have anything in common? Nope. So I just multiply them together and get a 6. If I change the denominator, I must also change the numerator. Using the pattern called what? Divide and multiply. So first I'm going to take 6 divided by what? 3, which gives me a 2. And I'm going to take that 2 times the entire numerator. In this case, it's 2 terms, right? So 2 times 2x is? 4x. Good. 2 times negative 1 is? Excellent. If you have a sign in front of a fraction, you need to move it up to the numerator. Now let's do the next one. 6 divided by 2 is 3. And 3 times negative 1 is? Am I done? No, because those are like terms. So will the 4x change? No. What's negative 2 minus 3 going to make? Negative 5. Excellent. Still over what? 6. And now I can divide that 4 and 6 by 2, right?
No.
Why not? Because the 5 doesn't, right? You cannot simplify unless something divides evenly into how many of them? All of them. These 2 would divide by 2, but this one won't. So you can't divide any of them by the 2.
Wait, what does 1 look like if you can divide it like 5?
So like if you had 4x minus 8 divided by 6, will those all divide by 2?
Yes.
Then you can divide them all by 2, which will give you 2x minus 4 over 3 when you're done. Right? Okay? But unless they all divide, then don't worry about doing it to any of them. Okay? Right? So 4 and 6 will divide by 2, but the 5 won't, so you can't divide any of them. Okay? We have to play nice. Okay? I don't know. It just sticks in your head after 20 years.
Is it 3?
All right, there we go. Now, okay, hold on, guys. Now, These are some fairly simple fractions because what I'm trying to get you to focus on is the LCD part, and change. If you change the denominator, you must change the numerator, right? They are going to have more to them because when we come back, this is what we're going to start doing after we're going to do a lot of revision first. But then after we come back from the practice exams, we're going to be working a lot more, and these are going to get bigger. Okay? But you need some more knowledge before we can do that. And you just don't have time for that before them. Okay, so what page did we work on?
24.
And we did the...
Even.
So that means your homework is the odds. There you go.